Let me introduce you to the scenario we're going to use for this module. Right now I have a very simple MVC application with almost no content inside. There is a home controller and there is an index view, but they do almost nothing but just render some simple text so far. But I do have the application set up with a lot of the infrastructure that I need later on. So if we look in the layout view, you can see I'm including Bootstrap. Bootstrap.css is a CSS framework you can include in a project to take care of your layout and typography. I also have my own custom style sheet, styles.css included, and the JavaScript library Modernizer. I'm including Modernizer at the top of this file because, as you might know, Modernizer is a library that detects features in a browser and in a few cases adds HTML5 capabilities to older browsers, and in order for it to work properly, it needs to appear before the body of the HTML document. And I'll also just point out a new feature in Razor here, which is that I can use the tilde in the source attribute of links and scripts, and Razor will find it for me and generate an app relative path. So this will work regardless of the URL in the browser, and this is a lot cleaner than what we did in previous versions where we typically use the URL helper to generate the URL. Here at the bottom of the layout view, I'm including some additional scripts that the application will ultimately need: jQuery, jQuery UI, jQuery validation, the MVC unobtrusive extensions for jQuery, and a templating engine called Mustache. I like it because it has a data binding syntax that is not obnoxious. And I'm loading all these scripts at the bottom of the page because I've heard it's a good idea to load your scripts as late as possible. That allows the browser to download all the content and get something on the screen while the scripts load later. Before I run this site for the first time, I'm going to go into a program called Fiddler. If you've never used Fiddler before, this is a free tool that you can use and download to debug and fiddle with HTTP traffic on your machine. You can just search the web for HTTP Fiddler, and I'm sure you can find the download link. I already have it up and running. I'm just going to go into the Rules section and go to the Performance section and check off two boxes here: Simulate Modem Speeds and Disable Caching. Disabling the browser cache will let me get more accurate timing measurements, and simulating modem speeds, this is a bit drastic, but it will make my optimizations easier to demonstrate because the numbers will be more dramatic. And in reality, there's a lot of people who run at modem speeds. My fancy 4G smartphone has more processing power than my first personal computer, but it spends a lot of time making 2G connections on the web and it feels very slow at times. So I'm simulating life with my cell phone provider, and I want to speed things up for myself. So with this all in place, let's go to Internet Explorer, where I already have the developers tools open. You can open them with the F12 key, and I'm on the Network tab where I will click Start Capturing, and now let's initiate a request to the application. I'll come back later once all this is finished. Now the page is fully loaded, and it took almost a minute. I can tell by going to the detailed view on one of these requests and then switching over to the timings tab. I can see it was 56.1 seconds from the time we initially requested this page until the time the DOM was fully loaded, the DOM content loaded event fired, all the scripts and style sheets were in place. Almost a minute. That's slow. And if I go back to the summary view, the DevTools will also tell me there were over 897,000 bytes received for this page. So there are two ways we can improve the page load time. One is to reduce the number of bytes that we send to the client. You can see that jQuery was almost 250 kilobytes, jQuery UI was over 360 kilobytes. Those are our two largest assets. And if you already know about minified files, you might wonder why I don't serve the minified versions of these jQuery libraries, but we'll get back to that. So size is one problem we want to solve, and the other problem we want to solve is the number of downloads the client has to make. It's a little hard to see here, but some of the downloads needed to wait for other downloads to finish because every browser only makes a finite number of connections to a server. Internet Explorer was the most cautious browser. It would only allow 2 concurrent requests to a single server. Starting with Internet Explorer 8, Internet Explorer now allows 6 connections to a server. I can always verify that by going over to the JavaScript console and asking for the window.max connections per server property, and that shows me 6. So most modern browsers make between 6 to 8 concurrent connections to a server, but when you have 10 resources to download, this means that a few of them will need to wait for other connections to free up before they can start downloading. And if I look at one of the last resources to load, like mustache.js, and again go to the detailed view on the timings tab, it will tell me that it didn't start downloading until after 0.82 seconds after the initial request. So it took almost a second to reach the point where we could even start downloading this particular JavaScript file. And this is the scenario that ASP.NET Web Optimization set out to improve. We have a page that takes nearly a minute to load over a modem connection, and we're downloading nearly a megabyte of data. Let's see how we can improve this.